Hello everyone, welcome to what will be pre-lecture 18 that'll cover chapter 2.6, point 9, and point 11. So hopefully by the end of this class should be able to determine what mass percent is, be able to calculate it for molecules, should be able to tell the difference between an empirical and a molecular formula, should be able to calculate an empirical formula for a molecule given the mass percent, and you should be able to determine what a limiting reagent is in a reaction and how much product forms from a limiting reagent reaction. Okay? So let's start with percent by mass. And so if we know the compound of a formula, the percentage of each component can be determined, and by component there I mean each element, can be determined by finding the ratio of atomic masses for each element. And this is what we call percent by mass. I'll also use this abbreviation here, mass percent, throughout class. Okay, so say we have the molecule ethanol, CH3, CH2OH. What is the percent composition of each element's mass? And so we pretty much want to break this into two steps. Want to calculate first the average mass, aka our molar mass or molecular weight for our ethanol molecule. So we have two carbon atoms, multiply that 2 by the average mass in AMU that we get from the periodic table for carbon. We have 6 hydrogen atoms, do the same there. We have 1 oxygen atom, we do that. And when we add all those up, we get 46.068 AMU. We could also call that 46.08 grams per mole, right? So that is the molecular weight. That's step one. And then all we need to do is take each component. So we have 2 carbon atoms for a mass of 24.02. And we divide a part by the whole. So that's what, anytime we have a percentage, we divide the part by the whole and we multiply by 100, we get 52.145%. Excuse me, and that's for carbon. For hydrogen and oxygen, we would do the same things. So we take their total masses, divide the part by the whole, and we end up with 13.127% hydrogen and 34.729% oxygen. Okay, and that would be finding mass percent. We can also use mass percent to calculate an empirical formula, and so I'll walk through these steps here. So if we know the mass percent, it can be helpful in determining the molecular formula. And so let's say we have methane here. If we know that methane, or we're told that methane is 74.9% carbon and 25.1% hydrogen, what is its molecular formula? We can start step one by taking 100 grams of methane, and this is one that always trips students up, but basically doing the opposite. So say we have 100 grams of methane, just pulling that number out because it's a nice round number, and the percentage that we have is 74.9%, so we set this up as a ratio. So 74.9 grams of carbon for every 100 grams we have of methane. That means we have 74.9 grams of carbon. Do the same thing with hydrogen, 25.1 grams of hydrogen per 100 grams of methane. Okay? With that then, we can use our molecular weight that we get from the periodic table for each element. So for carbon, 74.9 grams of carbon. We divide by the molecular weight of carbon, 12.01 grams of carbon for every mole. And we convert everything to moles. So we would end up with 6.24 moles of carbon, 24.9 moles of hydrogen. Then our final step is putting those two over each other. And I would always recommend just putting the bigger number on top, smaller number on the bottom. That way you always end up with whole numbers, and we should get a ratio of 4 to 1. So for every hydrogen, or every carbon that we have 4 hydrogens, and that is our empirical formula. However, there's a difference between an empirical formula and a molecular formula. So the empirical formula will tell us the lowest common denominator or ratio between atoms like CH4, whereas a molecular formula tells us the actual ratio between atoms that is not necessarily the lowest common denominator. So for example, with that work we did on the previous slide, we could have had CH4, that is a valid answer, but it could have also been C2H8, C3H12, and so on. Basically any multiple of 4 there for hydrogen and then carbon. So in order to tell what the actual molecular formula is, you would have to be given the molecular weight to know for sure what it is. And so if I ever ask you for the molecular formula, I will probably give you mass percentages, but I will also give you the final molecular weight, and you'll have to determine that. Okay? All right, that's it for the pre-lecture. Hope it was helpful. If you do have any questions, please let me know. Otherwise, I will see you in class.